Hey everybody, this is Larry. This is me going Q3 of the bi-weekly contest 144, Zero Array Transformation 3. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. This is the one that really messed up my contest for me because as you see, I actually did not solve Q4 and I would have solved Q4 because in like 20 minutes or so, and you can watch that video. But for this one, it's just tricky. I think so my thoughts on this problem, and look, if you're looking for an explanation, you can skip ahead a little bit, but I'm doing a little bit of a retro, a little bit of a postmortem, just to kind of figure out how I can get better, right? I think a more interesting question that people ask sometimes is like, how do I improve myself? And of course, it's very personal, very personalized to everybody, and that is the same for me. So what applies to me is not the same for you, and so forth. And my thought process, hopefully, me talking it through, will allow you to figure out how you can examine yourself to figure out how to get better. There are a couple of things, and this is maybe on the contest level, not just this problem, right? And also like just a whole matters thing, is that recently I've been working on, and again, you could fast forward this, but recently I've been working on getting fewer mistakes and just taking my time slower, right? Which is a choice, and definitely it allows me to be more steady, and I've been more consistent lately. Like I haven't had any blow-ups, but you know, for this particular problem, I took the same approach. But looking back, I think I should have been more aggressive. I should have gotten a wrong answer early on, and if I did, then I would have gotten that feedback. Remember, on these contests, you do get the test case sometimes, and given that 5-minute penalty, the obvious question is, would I rather have 5 minutes and take 5-minute penalty and take like 20-30 minutes, or do I not solve the problem? We know that one, or even taking like an hour, right? So I think these are things, and if I had done that, I would have realized that my greedy was wrong, and we'll go over why in a sec, but why greedy is wrong is very easy, right? All you need is a counter case, honestly. But I would also say that there are a couple of reasons beyond just that for why I thought it was right? The more interesting thing was why I thought my greedy was correct when it was in fact wrong. The short answer is because I thought I was thinking of a similar problem, and I didn't really and I was thinking about the wrong similar problem. That's the short answer, and I needed a counter case, and I just didn't think. I was so convinced that I didn't think about it. And honestly, this is why, for every, I think this is a good example of a greedy attempt gone wrong, right? I think there are sometimes people tell me that, and I try to be very cautious on every greedy problem, honestly. But today, I guess I just didn't. I don't know. I'm not 100% today. I'm on about 36 hours of my 3-day fast. No food, no water, nothing, right? Except I did take a shower, so nothing. But as a result, my brain is probably not 100%. So some of these is just about that process, right? But excuses aside, when could I have been able to get this? Yes, because I got this as soon as I got the wrong answer. Very close to after I got the wrong answer, I re-examined it and I got it. And you can watch this during the live portion, which is afterwards, right? But okay. But this is also why when people ask me or tell me that like, hey, this is a greedy problem, and then when I ask them what's the proof, and they say, oh, it's intuitive. But I would also say that every wrong greedy solution is also intuitive to someone without the wrong answer, right? And this is why I properly try to prove it, right? Or like at least a mini proof. I try a little bit. I think that people who say the greedy solution is obvious and intuitive for most greedy problems, not just this one, I would say that it just means that honestly, for me, it just means that you haven't solved enough problems. You haven't eaten enough. Let's just say pie, to know that there are hard, greedy problems in which you can be wrong with, right? And even this one, even though I kind of downplayed this a little bit, only 500 people got it, so not even that many people have gotten this one, which for Q3, for a easy, greedy problem, it's still pretty hard, right? So let me go over what I thought was right first. Let me bring up the drawing board real quick. But I think these are caveats, and also to say that, you know, you don't understand a greedy solution either here or in general. It's not always you. I think sometimes people just underestimate the proof necessary, and when people are like, oh, it's just obvious and greedy, I'm like, listen, right? That's what I would say. So I mean, I think the first thing that I would say is that this kind of harkens back to the problems of last week, right? I did the weekly or bi-weekly, I forget, but there are similar problems. So definitely, because this one is zero array transformation 3. Check out my videos on zero array transformation 1 and 2. I think they're like Q2s and Q3s last week or something. I forget which one, but yeah. But the idea here is just the first idea is to think about this as, you know, you have these constraints, and yeah, how many numbers do you fit, right? So so for example, yeah, so I have a number line, right? And the number line is num sub I, right? So maybe in this one you have a 2 requirement, you have a 0 requirement. This is 0. I just want to okay, and then 2, right? This is the first example, and then now you have all these queries. Change the color real quick, and you're trying to take the minimum of them, right? Like as few as possible, right? And this is where, so my initial idea is just do a sweep line, right? So we have these sweep as we go left and right, and we can, I thought that you can greedily choose whenever you see a new thing, you just kind of keep track of the things that are inside. And I kind of I think the idea is kind of right, but how I picked was not right? So initially, the way that I thought about it is that, okay, as you sweep from left to right, okay, this is satisfied, so then now we know that this is good, and there are 2 things inside, and then as you sweep, you go, okay, well, you go here, well, the 2 things are still in here, so we are pretty good, right? So as we sweep, we just keep track of the segments that we used. And the way that I kind of thought that it would work the first time, and this is a very subtle thing, is that I did a last in first out, so I did it by queries. So here first I sort the queries by the left endpoint, and then greedily choose the right endpoint. But as a result, greedily choose the right endpoint. But as a result, I made a mistake in that there is a case in which it was 0, 1, 2. And in which, for some reason, so this is like a thing, right? So the ideal solution is just these 2, right? But my algorithm chose 3 because on a sweep line, the way that I swept, I just didn't really visualize it enough, and I don't know, I was missing something. As I swept, as I got to here, I go, oh, I need something. So as a result, I kept this, and then I just kind of keep sweeping, right? And I kept this, I'm good, and then now I'm here. So then here, I also kept sweeping and kept this for some reason. I mean, you can say, you know, yeah, I kept this, and then so now I returned 3. Honestly, though, I think I just didn't have the right visualization. I think my idea, the reason why I was wrong is because I think I was thinking of a different problem. The problem I was thinking of is the one, because I think there was also a similar problem last week, or maybe the week before, right, where I had to care about the intervals, right? So I care about the intervals, and the reason why I did the sweep thing like this on the intervals with the right endpoint is because then now I don't have to care about, like, I care about the number of intervals that I would need, almost the other, like the opposite of what I need. I care about the intervals and what they intersect, and I try to finagle it to get it right, but I just couldn't. It turns out that the other way to think about it, the correct way to think about it, in a greedy way, is just, actually, it's the same idea, really, but selection a little bit different, right? And what do I mean by that? Let's say I have, 0, 1, 2, right? Again, 0, 1, 2. The key idea is that, okay, we don't have to choose what we use until later. Oh, this is kind of wrong, actually. I think I had this, and this, right? I don't have to choose until later, right? Until I absolutely have to. And when I do, I could choose the latest, right? I think that's the key part. So what do I mean by that? What I mean by that is that, okay, so we have this, I sweep left, right. I don't automatically include this yet, right? But here, let's say I sweep to here, right? And then now I need one item. I go, okay, I need one item. My current thing, I don't add this yet. My current thing is that I have zero things in the thing that we care about, and then now I have two things to select, right? Because here I have two segments that I can choose that will start with one element. And here, of course, we're going to choose the greedy one, which is the longest, because the previous doesn't matter anymore, so we can always choose the one that goes farthest. And here it is this one. So here we choose this one, and now we have one thing into the thing, right? And now one thing in the selection. And then so you go right. So now we're at this point. We have one thing in the selection, but we need two, right? So because we need two, we need to select another thing. And of course, at this point, well, this one drops off. You do the math on removing it. Yeah, and then you just take this obvious one, which is 2, right? And of course, after that, it just becomes like a easy visualization, and it is greedy in that case. I'm going to rewrite another example to just go with you what I mean, because I think that was the case that mattered to me because I had an issue. But let's say you have 0, 1, 2, 1, 2, right? Maybe that's a little bit more illustrative for a more general case. Is that okay? As you sweep, so let's say you have this segment, this segment, and maybe just like this segment or something, right? Yeah. So then now, if you sweep here, you have nothing. Here you have these two things to select from, and we need one. So then we of course pick this one, right? And then here, well, here now we have a greedy thing again. So we choose this one, right? And keeping in mind that we pop this off, right? This is poorly drawn. And as we drop this off, we could choose this one. And because we need 2 and we only have one thing inside, we pick this one. And so now is this one and this one, we have 2 inside, right? I actually kind of messed up a little bit, but yeah. But let's say you go here, then now you remove this thing from consideration. Well, this one, you just, actually more critically is that you, here, change the color real quick. For this one, you have to remove it from for the things that we currently have, so that now we only have one thing inside. But of course, one thing inside is good enough for this. And then here, now that we go up to here, we need 2 things, but we only have one thing inside the current set. So then now we return -1. Or of course, if there are more segments, you could have chosen them. But that's the general story. All right, let's go over in code and go over what I mean, right? And the code is pretty straightforward. Here, I don't know why I wrote prefix. Well, the reason why I wrote prefix is because initially I thought about some prefix, some things, and you can make it think about an event. Like if you put event, then this is just the event, right? And what I mean is that at point X, we add these events so that we can keep track of things, right? And that's pretty much the idea. So that we know that at point X, there's a new interval. And here, point Y or whatever, the endpoint, the Y endpoint, we do a -1. And we just made a list because we don't care. But for index, I keep track of Y. Though I guess that's actually in nums, but whatever. Or in queries, that is. Yeah. And actually the sorting doesn't matter. I had this greedy sort because of another way, the way that I was doing on the segment, right? On the segment, I was thinking about like merging segments and stuff like this, and that's why I had some greedy sorting. But like I said, I was thinking about it in terms of segment, but I should think about it in terms of nums and events happening on the nums, and that's where I went wrong. So okay, so we have three things. We have used. Used is kind of keeps track of any of all the queries that were used, right? And I put these as set, but honestly, they don't need to be set. They could be all be Boolean values, right? Because it's just times q, right? And of course, q is length of queries, right? Right, and then now current is also well, current we want to use set just because it let me do this pretty quickly. Though you could keep track of it, of course, but you know, but yeah, and I mean, yeah, I mean, I'm just gonna keep this as set because I'm too lazy to change it all. But you could use Boolean on all of these. But yeah, the idea is that, okay, now given the list of event, we're at index I, so we look at the index that we care about I, and then here we have, this is actually the index of the queries, so maybe Q index if you will, just to kind of keep track of it, right? And so then now, oh yeah, current is the current set of queries that we are currently using, right? And then we move this lazy removal of the set that we don't that we should not consider. And this is lazy. Why did I say lazy? Is because on the heap, we don't remove it from the heap because there's no easy way to remove things from the heap except for when we pop, right? So okay, so in this case we have on the nums index of I, we look at all the events that we have there. We have the index, which is the Q index. Let me actually rewrite this as QI for Q index. I think that's how I had it before, later anyway. Right? And well, after I make all this change, let me kind of run the code real quick. Yeah, and I missed a place. Missed it in two places. And then let's give it a quick submit just to make sure that okay, yeah. Yeah, and then the idea is that, okay, if this is thing, push this into things to consider. And heap is H is a heap that lets us decide which query to use, right? And that's basically it. So if we have one, that means that we have a new query that we can use, and we push it to the heap, and we want k is, I don't know, oh, k is the right side, right? So maybe we could even say right? And if this is right on the right side, basically of that interval, if t is equal to 1, right is going to, and you know, we don't do anything on the other side, but we use e, meaning the endpoint, right? So we want to sort by this because we want to be greedy on the greatest as possible. So on heap, we just push the right endpoint, the index of, or yeah, the right dimension, the x dimension of the index of the right side or whatever, right? And we want to sort by the greatest, and we keep track of the index, so we have qi. And then if it's -1, meaning that we're removing something from the current set, things to be considered, right? So these are things to kind of add to heap only, and this is how we add to heap, right? Yeah. Well, actually, this is how we add to heap. This is a lazy removing of. This is how we remove things from heap. This is how we lazily remove it from heap because we cannot remove it from the heap directly. And also, if the current index is if the current query, or if the query is in the current set of queries that we're currently using, then we can remove it because it just finished, right? So that's the idea here behind this one. And then now, length of current is going to be the number of current queries that we care about. And if the num sub I, which you can think about as a requirement, if the requirement is higher than that, then we need to add more queries. And how do we choose queries? Well, we choose queries by reading off the heap, which are the things that we care about, right? The things that we can consider. Yeah, and here we pop from the heap. We don't care about the right index actually because we don't care about the right index because we already factored that into the events, so it'll get factored in the future. But yeah, if it's already removed, that means that we already previously removed. I guess you can, if you do write the right index here, then yeah, if you keep track of the right index, you could track that the right index is actually before this. So maybe you don't need removed as a different set, but I don't know. It just keeps it easy for me. But yeah, actually, yeah, yeah. During the, well, this is after the contest anyway. But yeah, during that I didn't have to think about it. But yeah, otherwise, then now you add current as you add the query to the current set, and also that we used it at least once, right? And that's pretty much it. And then at the end, the length of the number of used queries is the total of all the sets of things we used, and queries, well, that's just the length of queries. So these are the things that you can remove, right? Because these are the minimally used. And that's pretty much it. What's the complexity here? Yeah, the only thing that is going to be expensive is the heap, right? So for each event, or for each index, we add once and we remove once, right? So that means that it's going to be log q, right, for the number of queries, and for this is O of n, it's going to be n log q is the complexity, and O of q space, right? Because all these could be O of q. Yeah, nothing O of n actually, which is kind of funky, but yeah. Okay, so that's pretty much the idea, is that you just keep track of things that you have to consider, and then only when you need to, you take things off the set. You take greedily the thing to consider. So very silly mistakes by me, but yeah, I think that's pretty much the idea for this one. And yeah, so and you can do the lazy removal in different ways. So I'm going to upsolve this a little bit with you watching, but you can also skip forward to the live portion during the contest where I spend an hour and more doing this silly thing, so you can watch that. But yeah, so here you don't even need remove. You can just write, yeah, so this is the index, right? So this is the right index, and let's flip it back to the right side, and then here if I is greater than right, then we continue, because that means that we are bounds. Yeah. Oh, I think I removed the wrong thing actually. We could remove this thing, not the other thing. Oops, wasn't even paying attention there. This may be off by one, so but I'm going to YOLO submit. Okay, so yeah, so you could see that we don't even need it. We just need this for the lazy heap, if you will, because it means that it already ended, right? Definitely a number of ways to do it, but yeah, that's all I have for this one. Let me make it slightly smaller so you can see it for me. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live during the contest next. Well, not during the contest, afterwards, I guess. But during the contest, I struggled, and then I solved the next. But yeah, next. I'm just being... If it times out, I'll be very sad. Okay. I wasn't sure on that one, actually, honestly, about the timing out. A little bit slow, but that's fine. We can catch up on this. Only 2 solves and 1 solve, so we're... that was a very long Q2, though. But, you know, let's go. This is like from last week or something, right? The maximum number of elements that can remove from queries. So basically choosing the subset of these, the minimum subset for which. Okay. I mean, people were talking about it during chat, but I don't know that I know how to do it, because I wasn't thinking about it. So we can move these. Okay. Is it by research? Is it? Well, it's not a 10-minute problem by smart people. So this is not great for me if I don't get it, but we'll see. So it's just greedy, right? By the same idea, I think. Yeah, okay, fine. And this is a Leetcode problem. This why this is a medium, but I forget how to do. Oh, like it's so easy to mess up. And off by 1, that's why I'm slowing it down. Basically, it's just sorting, right? And then something like this. Okay, that's just. I feel like this is a little bit unfair because of the previous problem. Like I've done a lot of the thinking, right? So I use similar ideas. I forget it, and wait, so I could actually just do something like. What do I want to write? That's not it. We want to no. I forget if that's a code. Okay, you have to check. I just forget, but you have to check that it exists. Like this. Oh, I never removed it. Oh well, for the best. Ooh. Oh, what the? Okay. CO2, CO2. Should have gotten removed. Oh, this is if still wrong, but okay. Oh, I'm not minimizing it. Okay, I mean, I think I could minimize this. One, two, three, 0 to 2. I mean, it's you could do it, Larry. Come on. It's just more bookkeeping. We want to count the first thing, right? So easy to get wrong. That's the watermark. Okay. You have to remove. No, this is negative, right? So then now. If num sub I is good. It's just lazy. Otherwise, then. Remove nodes. Okay, so then now, how many do we want to remove? Okay. I don't think that should be never happen, but the same thing. Let's see what we think it is. Didn't I have a print statement here? So 101. feels wrong, honestly. Because, yeah. No, this is definitely wrong. Why is... Oh, no. This is... No, but the index is wrong. That's why it's weird. Do I sort the index by accident? It should be 02. Why? Oh, no. Oh, I read it wrong. Okay, 01 is right. You could remove 2, right? Okay. Should be 1. Oh, 03. Oh, because it just never gets used. And then at the end they would do it. Okay, fine. I don't know. It's very easy to mess up, so I don't know that I'm confident. But also, this looks right, but this answer is wrong. This is clearly possible. Almost submitted it too. Why is it -1? Alright, well, I guess it's good that we did not submit, I suppose. I mean, it's just bookkeeping. I don't know that I'm doing anything that funky. Did I mess up I? No, you messed up printing. Okay, 02, 14, 11. This should be possible. Why is this wrong? Is this why? Okay. There's 1. You still need 1 more. Okay, so 02, 02. Okay, so going link with 4, everything's in it on the last element, okay? Two, but then you need 1 more. Is that true? That's not true. Delta shouldn't be 0. Current good is wrong, maybe. Yeah, current good is probably wrong. Should be the high watermark, but I'm doing that wrong. Not enough awake for this. Current good is 2, okay. Yeah, that makes sense. We're 4 inside, okay. I think this is wrong. Oh, okay, this is still wrong, but maybe this is slightly better. I don't know. So 3, so 3. So we're good. Delta is 0. Is true. This is not great. Oh, this should be -1, okay. This is -1, which we're right, and then this one should be... Oh, actually, maybe, no. How many, what are we returning? We moving? I need another state, I think. It's just a lazy remove, right? Where's this one again? Oh man, I'm not gonna do about this. Current good is 1. No, you already did that, Larry. Then why is current good 1? Because this gets removed. Okay, so there's 2 things, so now Okay, we fixed this issue, but this is still wrong. Why? 0 to 2. Because I do some overlapping thing. This is not that bad, Larry. Why are you so bad today? Alright. Zero to 2, okay. Delta is no good. Okay, so 0 to 2, that's fine. Alright, so then at 3, we have current good. It's still 1. Now, so we have to remove this. We can't get... before calculating the delta. We want to, okay. What is current grid again? This is just wrong, Larry. What are you doing? This counts the number of things that are done. In a lazy way. Okay, so then now... Okay, slow down. Okay, so current represents order index right now, okay. And current good should be the prefix of everything that we've already done. This is very wrong. This doesn't even make sense, the code. Okay. So we want to do a lazy removal. Okay, because I'm mixed here. Okay, so I'm just being dumb today. Let's put my case back in there actually. Okay. All right, this one makes sense. Maybe not. Maybe my thing doesn't make sense because you're retracking it. But then how does this even work? I'm just doing very poorly. Okay. What am I doing? Okay, reset. should make the Q4, but it's too late. Let's think about this. I still want this to be a list, I think that's why. So current good is equal to prefix, so if so it's in the prefix we remove it, otherwise we want it. So this is the wrong one, which is good. We still have it wrong. One and two is on a queue. Okay, that seems right so far. Okay, just converted to 1, though it should not have. Oh, I am dumb. Am I? I mean, yes, but... I'm not even have a chance to get a look at Q4. Two is removed, but 1 should not be. This is the index of the query, so this is right, this is wrong. I'm just dumb. But now this is wrong again. This thing again. Still wrong. Is current good? If it isn't to remove them, we just ignore it. is not having a good day. I'm just confusing two things. Okay. This is the number of numbers after. I think I'm trying to do two things at the same time. Okay, so that is the number of new good things that we have to factor in. Okay. No, that's not right. That's just a prefix, right? And then now I have to keep track of number of things that are good that are done in the prefix. Okay, so this current good, which is the current prefix processed. Okay. Right. Okay, so if this we increment anyway, right? But this is not right. We have to do the high watermark thing, which is that okay, I mean, this is fine. It won't give me the right answer, but it'll give me an answer on whether it is good. So it's just a prefix, right? Why isn't this right again? Oh, because of this calculation, so I have to figure out how much to retrieve. Okay. That is a combination of what I had before, I think. That's still not the prefix. I don't know what I'm doing anymore. Oh man, Larry, what are you doing? What are you doing? Why are you so bad at this? And this one maybe is even doable. 186. I don't know. This is just a disaster for me. Maybe I should not have done it on no sleep and fasting. I don't know anymore. I'm gonna go like this. I don't remember why this doesn't work. That's why I'm like being dumb. But maybe we can stick to principles. So we move on. Right? Well, it has to be in order. So we move over. This is not cheap. We do a fake removal, right? That's why we had a current good. Is it a deck though? Maybe that's why this is weird. Okay, so let's say we had this, right? And now we want to. But we want a greedy one, right? We don't want just any one. Yeah, the way that I did this as well, maybe. I think this is it. Okay, so let's say now we go from 0 to 2. 0 those out. I have to reset. Okay, so and then is it just binary search? No, because yeah, it may come into play later. Okay, and then now we sort it in a greedy way. Segment tree. Still going. Why, ChatGPT? Why don't you just give me the... Subtraction is confusing, but okay. Is it inclusive? The example they give is terrible, so I don't know. Here's the number. Just want to double check my understanding of this. Alright. Why is this wrong now? Let me just get it right. I don't even know about Q4 anymore. So, okay, so 1 means that there are 2 queries. 2 queries means that you could remove. Oh, whoops, that's why. I meant it that way. You keep 2. I was like, and it's Q. Did I get this wrong before? I wonder if I was right before, but I was just doing the wrong variable. That would be funny, actually. With 7 minutes left, I have no time to kind of be careful now. Oof. Okay. Oh, because it did all the 0 zeros. I can't be greedy like this. I have to, that's the reason why I kind of did it the other way. I was confused. Okay, well. It may time out, but oh. Huh. I think I could remove 5, but you can actually remove 6. Okay, well, apparently I just don't know how to solve these problems. Two, 1, 2. But you could remove 1 more. Zero, 1, and 1, 2. But why don't I do that? I do though. What? Don't I remove 2? There's 8. No, this is right, actually. How do you keep 2? Which 2? Did I misread this problem? If I didn't have so little time. Oh, I mean. where's one? You need oh, 0, 1 is not right. Oh, because you don't do 0, 1. Okay, so my greedy is wrong actually. Okay, I mean, I don't know how to do it though. Then I thought I could. I mean, in this way, you still do the sliding window, but I'm just messed up. I should have skipped to Q4, but I thought I was close. Two minutes left. It's this sad situation. Well, not even really. I should have checked to see if I should have skipped. People did Q4 first. Yeah, I mean, I think this is my worst rating in a while, or worst finish in a while. I don't even know what the Q3 problem is, but or Q3 is this, but I mean, I had the ideas. I just don't know how to do it. How many viewers got this? 500 people. And I didn't do Q2 fast, so that's even worse. Okay, so I thought I could do segment tree, but no, that doesn't make sense, I suppose. I think my original sliding window thing makes more sense, but yeah, I don't know. Now I wonder if, because I was I returning Q minus count? I think I was. I think I was returning N minus count. Maybe that was what's wrong. Is that true? No. One of them was just wrong. It wasn't the Q issue. No, I returned length sub length of queries. No, I remember that. So I don't know. Yeah, I mean, so that no, that wasn't the issue. I needed to do sliding windows, but I just, or not sliding window, but a keep line tracker thing. Right. All right, let's do it the naive way first, and I think that all right. I mean, so the contest is over, by the way. At this point, I am not happy. I don't even know if I could do Q4. I just never skip to it because I thought I could do this. So then now we have the prefix thing, right? Now we go. Right, and then now let's just say ref. I don't know why I'm so. I feel like if I've gotten this, maybe I've gotten Q4. I don't know. I still haven't even looked at Q4. That's what I forgot. Okay, and if okay, I mean, so in theory we would actually write it this way, but without tracking. Maybe I Should have done it, but right. If so in theory, that's the way I would have written it naively, right? Pretty straightforward stuff. Just to make sure that this works. And this should time out, right? Which is what we expect, but then I'm gonna submit it now just because I know that it's gonna time out. Oh, maybe I should have just tested it then. Why is this wrong? We used 3, but they think we should use 2. So maybe my idea was just really wrong. Yeah, maybe my idea is just very wrong. Even though this is going to time out. So we want, well, 2 makes sense. Because then you have this thing. Oh, you want to use this thing and then this thing, but then that, and then 0, 0 would just mess that up. Because this is time sensitive. Or I think we need to just sort by. So maybe I don't know if I did that. Today my brain just doesn't work. Okay, hopefully now we time out. I think this is basically the same idea, this sorting, but this should time out, right? Is that why I didn't get it wrong? Oh no, this is still wrong answer. So I'm just really bad, and this is the same case as before, because 0, 1 works, right? I mean, we had the wrong answer before, so maybe I'm just really wrong on this. Okay, so I guess I had the wrong idea the entire time. It wasn't. I think I should have submitted more, maybe. Maybe getting this wrong case would have allowed me to kind of realize that I was just really wrong with my idea, because I would greedily choose 0, 1 to get the 1. So I guess greedy doesn't really doesn't. Well, it's not in this way. I guess what I could do is we have to keep track of the greedy thing that's inside, right? So maybe we will have something like a heap, right? I mean, sorting is fine, doesn't matter a bit. So we greedily choose the longest ring. Okay, I think I see it. I think I see it. Okay, I just need a heap. Nope. Heap. Maybe I should be more experimental. I was too afraid of the wrong answer, and I didn't experiment enough, I think. Because it was just that one little nudge of, okay, you still don't do greedy, but I missed this test case, and I was thinking that I just had to tune my algorithm, but I missed something very critically, which is that everything now you can choose to choose the greedy, not okay. Okay, so then now keep push. We want the max, so and then X is the index. Okay. I guess that's fine actually. And then now, okay. And then we can pop, right? Okay, so then we pop, we get key, which we don't care about, and then the index, and then the index. Okay, I am just dumb. Alright, up solving. Alright, just making sure no one spammed too much on it. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Hit the like button, especially to give me a little support for this poll contest. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.